Automatic Addison.
In this tutorial, we will create a ROS2 action. A ROS2 action is a communication interface that allows a node to send a goal to another node to perform a long-running task and receive feedback while the task is in progress, and a result when the task is completed. By the end of this tutorial, you will build this robot right here. A ROS2 action is useful for tasks that take a while to complete and where you want to know the progress and be able to cancel the task if necessary. Let's take a look at some real-world examples. Consider a robot vacuum cleaner. Instead of just starting to clean, let's say we want to clean a specific room. This might take some time and we want to get updates on the cleaning process. We create an action called Clean Room. This action will give us updates like 10% complete, 50% complete, and finished, and we can even cancel the cleaning if we change our mind. Now let's consider a mobile robot that needs to autonomously dock to recharge its batteries. This process involves multiple steps and precise positioning. We can create an action called Dock to Charger. The action provides continuous feedback about the robot's progress, such as approaching charging station, aligning with dock, making final approach, and charging connection established. The operation can be canceled if obstacles are detected or if alignment fails. This is particularly useful because docking requires careful coordination and monitoring. The robot needs to detect the charging station, align itself precisely, and verify a successful connection, all while providing status updates and handling potential failures. And finally, let's take a look at my favorite, a kitchen robot chef. So imagine a mobile robot with an arm that prepares meals in your kitchen. The robot needs to move around, grab ingredients, and use cooking equipment. We can create an action called Prepare Dish. This action provides feedback like getting ingredients, chopping vegetables, stirring pot, plating food. The cooking process can be canceled if ingredients are missing or if safety limits are exceeded. So I'm asked all the time, when should I use an action versus a publisher and subscriber architecture? Well, ROS2, publishers and subscribers, these are the basic building blocks for continuous one-way communication in ROS2. For example, you've got a temperature sensor constantly publishing the current temperature or a motor constantly receiving speed commands. However, sometimes we need to monitor the progress of a long-running task and have the ability to cancel it if necessary. This is where ROS2 actions come into play. They work very well for this use case. Now let's create a package. Open a terminal window. Let's navigate to the Yaboom ROS master directory, cd ROS2 source Yaboom ROS master. And right now we are going to create a package called Yaboom ROS master messages. So let's do that now. ROS2 package pkg create, and let's do build type ament CMake license BSD3 clause maintainer name Ubuntu maintainer email, put your email in here, automatic Addison at todo.com, and then Yaboom ROS master messages, enter. Now in ROS2, an action is defined in a .action file, which consists of three parts: the goal, which is what you want to happen, the result, what happened in the end, and the feedback, which are the updates while it's happening. And each part is separated by a line with 3 dashes. The first part, the goal message, describes exactly what you want the robot or system to do. Think of it like giving instructions to someone. You need to be very clear what you want. The second part, the result message, tells you what happened after everything is done. It's like getting a report card after finishing a task. It shows the final outcome. The third part, the feedback message, gives you regular updates while the action is running. Imagine tracking a package delivery. You get updates like package picked up in transit, out for delivery. So when you use an action, it works like this. First, you, the action client, you send your request, the goal, and then the system that handles the task, the action server, starts working on it and sends you progress updates, feedback, so you know what's going on. And when it's all done, you get the final report, the result, telling you how everything went. Think of it like food delivery. So if you're in the United States, you'd use DoorDash, you'd use Uber Eats. If you are in the Middle East, you probably use an app like Deliveroo or Careem. If you are in South America, you'd use iFood. You'd use, what's the other one? Rappi. So those are the two big food delivery companies down there. And think of a ROS2 action like this. So you, the action client, you put in your request for a meal, some food. Maybe it's pizza, spaghetti, salad. All right. The action server then receives that request. It then does some stuff with it. Okay. In this case, it would cook your food, cook your pizza, cook your spaghetti, cook your salad. And while it's doing that, it's giving you feedback and updates about what the status is. Okay. Your order is currently in progress. Then when it's all done, you get the final report back. Okay. Your food is done and your food has been delivered to the delivery driver. So that's how a ROS2 action is defined. It's very good in robotics for periodic actions that you're not doing constantly, but you're doing here and there, like pick up this object or go to this location, or what's another one? Go to charging dock. That's where ROS2 actions shine. Now let's create a file called timed rotation.action. This will be our action. So you get your feet wet with how to define an action. And this timed rotation.action, okay, will define an action for performing a timed rotation of a mobile robot with a specific angular velocity and duration. We also want to make sure that we provide feedback on the progress and status of the rotation and then return a result indicating the success and actual duration of the rotation. So I've got my terminal window open, and let's move to Yaboom ROS Master messages. Okay, we're inside the Yaboom ROS Master messages, and let's create two directories, makedir action and cd action to move inside there. Now we're inside. Now within this directory right here, let's create a file called timed rotation.action. So touch and then timed, okay, rotation.action. So that's how we do it. Capital T and then capital R, like camel case, but the uppercase version of camel case. So timed rotation.action. Okay. So now we've got to fill it in. So let's do get it, timed rotation.action. And let's define it. So first part here, I'm going to request parameters for the time. This is our request. So this is the goal. So request parameters for the timed rotation. Parameters. So these are the parameters that are involved in the request, the goal that you want. And we want to do float 64 angular velocity. Okay. So we want a specific angular velocity when we're doing a timed rotation. So we're going to rotate around at a specific speed. All right. I'll just put a comment out there so you know what that means. Say desired angular velocity in radians per second. Okay. So just to make that clear, by convention, it's going to be positive for counterclockwise rotation, and then negative for clockwise rotation. All righty. Let's see. I'm going to do rad per second. I want all of that on one line. Otherwise, that's going to confuse you. Okay. positive for counterclockwise. And instead of counterclockwise, I'm just going to go to CCW, counterclockwise, and then negative for clockwise. Rotation. All right, I want to get it all on one line so you don't get confused. So what's our other goal? It's a timed rotation, so we need to have something related to time. So let's have a float value, duration, and let's go over here and let's say desired duration of the rotation. Okay, now we've got to have our 3 dashes, and let's say result of the completed rotation, bool, success. This is our result section, and I'm going to say indicates if the rotation was completed, because we've got to get that success message back successfully to know, did you do the timed rotation effectively? And I also want to get in that result. I want to find out how long did it take? How long did it actually take? We had a desired duration in our request, but how long did it actually take? So I'm going to call it actual duration. Okay, and let's do actual duration of the rotation. Okay. And let's be clear what our units are. I'm going to say in seconds. Okay, and let's do 1, 2, 3. Now we're going to do continuous feedback. This is our feedback part during rotation. So float 64, elapsed time, and then string. We're going to string, and then here we're going to have the status. Okay, so the elapsed time is how long we've been rotating. Okay, so how long has, so let's just do a comment here. I'm going to say elapsed time, or how much time has passed since the start of the rotation in seconds. And then here, string status, I'm going to put here, I'm going to say current status of the rotation. And here's where we're going to put our different status messages. Sorry for the loud keyboard noise. Okay, goal received. Goal received. And I say the action server has received a goal. This is like the restaurant receiving the food order. So goal received. And then we're going to say rotating. Okay, and this is like food is being cooked right now. Food is being prepared. So the rotation is in progress. Then we're going to have goal succeeded. See, the rotation has been completed successfully. Goal aborted. The rotation has been aborted due to an error. Rotation has been aborted due to an error, or some exception. Okay. And what else? What else should we put for status? How about cancellation? So let's put here goal canceled. The client has canceled the rotation goal. Alrighty. So that's it. This is our action. That's how you define an action. We've got our request, that's the goal, the result, and the feedback. Now the goal message up here, you can see it includes the desired angular velocity and the duration. The duration's in seconds. Okay, then we've got the feedback message down here, and that provides information about the progress of the rotation. So we've got the elapsed time, Okay, right there is a float. How much time has passed since the start of the rotation, and the current status of the rotation is what we have after that in the feedback message. And it can be one of these: goal received, rotating, goal succeeded, goal aborted, or canceled. And then the result message in the middle indicates whether the rotation was completed successfully and provides the actual duration of the rotation. All right, so now let's go over to our CMakeLists.txt. We've got to add this puppy. Get it CMake. All right, we got ROS master messages. Find dependency. I'm going to uncomment that. And let's add this piece, which we're going to need. So find package, ROS IDL, default generators required. ROS IDL default generators required. Okay, we need this for our actions, and let's put this piece in there. So ROS IDL generate interfaces, curly braces, project name, okay, and let's do a action / timed rotation dot action, and then close that with a double quote. Sorry. Okay, so let's go through here. ROS IDL generate interfaces, action timed rotation dot action. So that is how we need to structure our CMakeList.txt so that it knows that we actually have that action defined. So after you've done that, save it. Okay, let's clear. And now let's fill in the package.xml. So I'm going to do edit package.xml. Got everything bare right now, which is how it should be. Okay, so we've got boom ROS master messages. Let's add a description down here. I'm going to say custom messages, services, and actions for the boom ROS master robot. Boom 2, BSD. Okay, and we need another build tool depend down here. And let's go through here. ROS IDL default generators. Okay, ROS IDL default generators. Let's build tool depend. Down here, let's do exec depend. And we're going to do ROS IDL default runtime. Exec depend. Need to have that piece. Okay, and then down here, I'm going to add this piece, member of, you don't need to know what all this is, just make sure it's in here. So member of group. Okay, and we're going to do ROS IDL packages. Member of group. Keep making these fat finger mistakes. Okay, so take a look at that. Make sure that your package XML looks like this. Okay. Make sure it looks like this. And when that's done, you need to save and close. Okay, now we need to build everything. So I'm going to open a new terminal window to do all the building. And let's go to CD, ROS2. Let's just go to the ROS2 workspace and type this to make sure we install our dependencies. ROS-dep install from paths src ignore source y. All raw acquired ROS-deps installed successfully. Now we clear. Now let's do a : build. And then after that, we want to source the bash, rc. By the way, I've got that build alias, which does that again. So we can do the build right there. That does the same thing as : build. Okay, actually it CDs into the workspace, changes directory into the workspace, and then runs : build, and then sources the bash rc. And I'll show you that here. So we'll do alias build. You can see this line right here. So this alias build, we CD into the workspace, run : build, and then source the bash rc. All right, now that we've built everything, let's check that the action definition exists. So we're going to do ROS2 interface show yaboom ROS master messages. See, ROS2 interface show yaboom ROS master messages / action / timed rotation. Yaboom ROS master messages unknown. Oh. Yaboom ROS master messages unknown package. Let's do ROS2 package list and let's see what's going on. Oh, interesting. Let's do a build. Okay, let's do again. ROS2 package list. Yaboom ROS master messages. It does exist. Okay, so let's run this again. Let's do boom ROS master show. Oh, okay. So not sure what happened there, but so we do ROS2 interface show yaboom ROS master messages action time rotation. Okay, there we go. Probably did not source the bash in that other terminal. That's what happened. So I built in the other terminal and went back, it didn't source. Okay, so now you can see our definition here. And if I had smaller text, it would all appear in here. But you can see it's the same text file that we had earlier with the request up top. Okay, angular velocity, duration, and then the comment describing what it is. Then we've got the result, which is both the success and actual duration, and then the feedback message right there. So if the action definition exists and is properly generated, that command right here, I'll show you again, ROS2 interface show yaboom ROS master messages action time rotation will show it all. And if the action definition doesn't exist or it's not properly generated, you'll see an error message indicating that the interface could not be found. Now it's time to write our action server. That's like the cook, the restaurant that's going to handle the order from the client, which is you ordering the food. So we're going to write in C++, and we want our action server to handle the ability to receive goals, okay? And remember, the goal was the angular velocity and duration for a time rotation. Okay, then it needs to give feedback, and we need the ability to cancel the task while it's running. And this server should also publish the velocities to a topic, and this topic is going to be mecanum drive controller CMD val. Okay, and that's going to control the robot's rotation. So the action server receives the goal from the action client, which specifies the desired angular velocity and the duration for the timed rotation. Okay, and then it's going to need to publish the velocity command. So let's dive into where we're going to do that right now. So I'm going to go to CD ROS2 workspace source Yaboom ROS master system tests. All right, let's see if we've got an SRC. We do. SRC file. Okay, and let's put it in here. So let's do touch, timed, rotation, action, server.cpp. Okay, and let's do get it timed. Okay, so now it's just all blank. And I've downloaded the entire repo onto my local machine from GitHub. So let's find it. We're just going through this manually so you can see all the steps. But in a real scenario, you're prepared. So I'm going to copy all of that. Okay, I'm going to copy all of this timed rotation action server.cpp. I'm going to place it into my blank file. See if that's good. Got it all there. Okay. All right. And I like to put really, really detailed comments in here so that you understand what's going on. So you can go through here. But in a nutshell, what this program is doing, it's subscribing to the action topic. So it receives goals from the action client. And when a goal is received, the action server extracts two things, okay, from that request: the desired angular velocity, okay, desired angular velocity right there, and the duration right there, how long we want to rotate for. The action server then publishes the velocity commands, okay, to the mecanum drive controller CMD val topic to initiate and maintain the robot's rotation. So it's going to set the linear velocities in both the X and Y directions. Okay. And then the angular velocities around Z to the specified value in the goal. So remember, we're just rotating. So our linear velocity is going to be 0 for both the X and Y directions. And the angular velocity is going to be non-positive. Okay. Non-zero. So if it's positive, we're going to rotate counterclockwise. And if it's negative, we're going to rotate clockwise. And this is in radians per second. So get the goal, do the rotation, sending the velocity commands, provide feedback while you're doing that. And then at the end, so once the duration is reached for the desired timed rotation, the action server needs to stop publishing velocity commands and then send a result message back indicating, yes, success on the rotation. Okay, as well as the actual duration of the rotation as well. And now if any errors occur during the rotation, the action server needs to stop publishing velocity commands and then send a result message indicating the failure. All right, so here is our code. Here's our code in all of its glory. So all of this complicated C++ stuff it's all structured like that. Like in here, you can see the different sections, handle, goal. But this is a template you can use for any kind of action that you develop. And it's quite a bit of code, but don't be intimidated. I've got really, really good comments that describe each step, telling you what to do. All right, now we're going to stop, save that. We're going to stop here. All right, and let's close that out. Let's close that out. All right, let's close that out. Okay, and now what we need to do is let's go to the package.xml, clear, get it package.xml, and let's see if we've got all our dependencies in here. Okay, here we're going to go depend RCL CPP action and then depend. And then we're going to go depend, and we're going to go geometry messages depend. Okay, and then we're going to go stood messages. These are all the dependencies we need for that action server we just put in there. Depend. Let's do stood messages and then depend. RCL interfaces. Let's see. In alphabetical order. So GS, actually RCL interfaces needs to be down here. Stood messages. Okay, and then we also need, because we've got our action depend, boom, ROS master messages depend. Everything good? Yep. Looking good, looking good. Okay, save that. Close it. Now let's edit CMakeLists. Okay, and let's take a look at that. Mint CMake, CLPP action, geometry messages, stood messages, RCL interfaces. We need to add one more down here. Let's do boom, ROS master messages. Boom, ROS master messages required. Okay, config launch. Got our square, canum. Okay, we need to add our timed rotation action server that we just created. So let's go underneath. We need to add that executable. Let's go underneath this piece right there and add this block of code from lines 34 through 37. So add executable, timed rotation action server, source timed rotation action server.cpp. Save. Okay. Anything else? We need to also specify the dependencies. So I'm going to underneath the dependencies, add this block right here. So amint target dependencies, timed rotation action server. We've got RCL CPP action, geometry messages, and then boom, ROS master messages down here. And we need to update our install targets. Timed rotation action server. All right, save that, close it. Okay, and now let's open up a new terminal. Let's build and hope everything builds fine. If not, we'll go troubleshoot it. Build, see how we do, how we do. Please build. There we go. Built fine. Good. Excellent. Now let's launch the mobile robot. Okay, let's just do that. Just do a quick build again before we launch. All right, let's clear again. So You remember from previous, I'll show you the alias here, from previous tutorials to launch our mobile robot, I've got a bash script to do that, and I use an alias called x3. So let's launch the robot. Okay, gonna close, open up a new terminal window so we can get ready to launch the action server. So let the robot come up. Let's go check it out in Gazebo. RViz. Let it do its thing. Take some time to come up. Okay, the logs have stopped. Everything looks good. Everything looks good. Okay, and let's go to our new terminal window. Now let's launch the action server. And to do that, we'll do ROS2, run, yaboom, ROS master, systems tests, and then timed rotation action server. So now our server is running. Okay, and let's open up a new terminal window. So to see the list of actions a node provides, in this case, we need to run this command, ROS2 node info timed rotation action server.cpp. And you can see right here, action server right there. All the different parameters and publishers. See our CMDVal right there, publishers. And then some other standard services which come boxed in here with this node. Okay, and to see all the active actions, let's do ROS2 action list -t. Okay, this is the active action right here, timed rotation. Now, if you want to check the type of action for the action, you do ROS2 action type timed rotation. That's the type, which we defined earlier. That's clear. To take a closer look at the action, we do ROS2 action info timed rotation. Here's our server right there. Closer look. And in clear. Now, you have been waiting for a demonstration of how to actually send a goal to the action server. And so to do that, we do ROS2 actioned, and then we do the send goal command, send under goal, underscore goal, and then the timed rotation. Okay. And then, so that's the action topic, and then yaboom, ROS master. We need to put the type here of the action, ROS2, ROS master messages, action, timed rotation. Okay, and then now is where we fill in our request. So we want duration. I want 15 seconds. I want a time rotation of 15 seconds. And I want it to spin angular underscore velocity of minus 0.25 radians per second, quote, and then feedback. Okay, we want to see the feedback. And when we press enter, waiting for action server to become available, we are rotating, so you can see in here, and you can see the feedback, the elapsed time. So you can see we're rotating in Gazebo. You can see the feedback being given, the elapsed time in seconds. And then we get a final status message which shows succeeded in the end. Okay, pretty cool. So rotating again, going to go to terminal. Let's do ROS2 topic echo mecanum drive controller CMDVal. Enter. And we can see the velocity right here, angular velocity was minus 0.25. Now it's 0. Let's just run that one more time. Okay, we're rotating. You can see the angular velocity is coming over the velocity topic. And that's exactly what we expected. So our server is working. Press Control C to close everything out. Now that we have written our action server and tested it, it's time to create and test an action client in actual code, which is what you do in a real robotics project. So we tested our action server for controlling the robot's rotation. We're now going to create an action client that can send goals to that server. Okay, we're going to do that in code programmatically to request timed rotations. We want to be able to monitor the progress through feedback and then receive the final results. This is particularly useful when you want to integrate the rotation behavior into a larger automated system or control sequence. So we're under systems test. I'm going to go back to the SRC file. Okay, and let's create a new file called timed rotation action client.cpp. And here we are. And I'm going to go down here to the downloads, systems test, source, action server. No, not action server. I'm an automatic pilot this morning. Action client. It's Control A, Control C. Let's go back to get it. We're copying and then put it all into here and save. Okay, let's go close that out. Close that out. All right, here is our action client code. And you can just go through that. It's got a lot of comments, but in a nutshell, what it does, it sends goals for a time rotation and it receives feedback and results. So got the goal, got the feedback, got the result. So it does the same thing you did in the terminal, okay? In the terminal, it does in code. All right. So let's close that out. Now we need to edit our CMakeLists.txt to make that code executable. Get it, CMakeList.txt. Make this puppy executable. So to do that, we need to add the timed rotation action client under the server right here. Okay, timed rotation action client, executable, got there. And we also need to under the server, where the dependencies here. Okay. So got the timed rotation action server and the timed rotation action client. Okay, and now we also need to add it installed executables here. Timed rotation action client. Okay, let's actually put it underneath the server since I'm adding these in the order in which I added it. So we'll make it here, timed rotation action client. Save. Okay, CMakeList all good. CMakeList all good. Now let's go over to here. Let's clear. Let's build again. We hope it builds. Should build. I've already tested this code before doing this tutorial. Okay, and it built just fine. Okay, now what I want you to do is let's source the bash. Let's just source the bash in each of these, bash RC, source bash RC, just so we got all the fresh code in here. Okay, do it in here again. Do it in here again. Okay. clear. Let's clear that. Clear that. Clear that. Now let's test our action client to make sure everything is working properly. So where did we run? Where did we run? Okay, so launch the robot. Let it rip. Then we need to launch the action server in a new terminal. And that's our timed rotation action server. Launch this puppy. And let's get ready to launch the client over here. ROS2 run. Yaboom ROS master system tests. Timed rotation action client. Okay. And you will, if we go back to the code, I want to show you something where everything's coming up. Let's go back to the system, the actions client code. So to trigger everything, okay, this action, this timed rotation, we need to publish to a Boolean command, so a true command to this topic, this timed rotation mode. So when this is true, that's going to kick in the action client, kick in the requests and the goal to the server. Server will handle it and then give us the result back. And in terms of our defaults right here, we've got a default duration of 10 seconds and a default angular velocity of 0.5 radians per second. So that's positive. So which way do you think it's going to go? Because it's positive, it's going to be going counterclockwise, rotating counterclockwise for 10 seconds. All right, and that's what we should expect when we publish to this timed rotation mode topic. And this timed rotation mode topic is right here. That's where we created our subscription. Let's close it. Is everything up and running? Everything looking good? All quiet? Good. Server running. Start the server. Is the client running? Client's running. Okay, let's open a new terminal window. Yeah, let's open a new terminal window over here. Now let's do ROS2 action info, timed rotation. Okay, we've got one action client, one action server. Let's check the topics. ROS2 topic list. And what was our topic name? We need to go search for it. Where is it? Where is it? Where is it? Where is it? There we go. Timed rotation mode down here. So ROS2 topic info, timed rotation mode. And we've got one subscriber. Okay, I did -VV to get verbose, and we can see that the subscriber is timed rotation action client.cpp, subscribing to the Boolean command. It's waiting to kick in, waiting to send a request. So let's do that now. We need to do a ROS2 topic pub, timed rotation mode. Okay, and then what type of message? Stood messages /msg/bool. And then we're going to do data. And we're going to do true. And then we're going to just publish it once. Let's keep this there. See if it moves. See if it moves when we do the publishing. Okay, let's make sure we get gazebo in the frame. Come on now. There we go. Okay, and let's press enter to publish. And you can now see we have rotation counterclockwise right there for 10 seconds. Okay, and if you want to trigger it again, you do false here to reset everything. Okay, and then do true again. So up, and then true. Rotating again. Now, if you want to cancel in the middle, okay, so it's done. But let's do a false again. Okay, and let's do a true. You could see the logs in our other terminal, but let's do a true, and let's cancel it in the middle. So to cancel in the middle, you want to send a false. Okay, real quick, false. And let's see if that got registered. Yeah, goal canceled. So receive cancel request. So that's how you cancel it. So you send the true to kick it in, and then you send the false right after that. That will get you the goal canceled. So let's press Control C in everything. Control C in every window. So that, my friend, is a ROS2 action. Congratulations, you created your first ROS2 action. And we do it in C++ because we like C++. C++ is lightweight and fast, but you can also do it in Python as well. I just prefer to do it in C++, especially when you're doing these things like moving a robot, dealing with motors and stuff. You want to use C++ because of its lightning speed and lightweight capabilities. Thank you for watching this tutorial. That's it. Keep building.